Okay, so this is lesson 5.1. Everybody had found the packet on their desk and everything, and you got your reference sheet out? Okay. Because you're going to want to know where these identities are on your reference sheet. All right. An equation is an identity if the left side is equal to the right side for all values of the variable for which both sides are defined. That's kind of specific. It's just saying that, like this question, I don't know if you can see it very well, x squared minus 9 over x minus 3. If you factored the top and simplified, it would become x plus 3. And that works because it's defined for everything except x equals 3. This equation is not an identity, okay? Because there's places where sine and 1 minus cosine are equal, but there's also places where they're not equal. Identities, trig identities, these include some of the basic ones. Cosine equals 1 over secant, okay? Tangent equals sine over cosine. Those are identities. We are going to move on today and talk about the Pythagorean trig identities, which is the ones that have squareds in them. But before we do that, I just need you to see that this notation, do you see that sine squared is really the sine squared, okay? We just write it this way so that we don't need these parentheses because it's not the angle that's squared. When I write this, it means the sine times the sine, okay? It does not mean the sine of the angle that's been squared. It's not that. And rather than having to put the parentheses and the squared on the outside, somebody came up with this notation. Any questions about that? When you type it in, if you type it in to graph it, you have to be real careful, but we can look at one of those later. The basic trig identity, sine squared plus cosine squared equals 1. I think we've talked about this all along because the unit circle has a radius of 1. So when we draw things in here, the x and the y are the sine and the cosine. So we just know this one and it makes sense. The other two weird ones can be derived from this. So I know a couple years ago, these kind of questions were on the University of Chicago's math placement test, and you couldn't use a reference sheet. Okay? But if you can memorize this one, the other two are just forms of that. If I have sine squared plus cosine squared equals 1, and I divide everything through by a cosine squared, okay, everything's divided by a cosine squared. What is sine squared over cosine squared equal to? Tangent squared, okay? Cosine squared divided by cosine squared would be 1. And over here we have 1 over cosine squared, which would be, so this weird one that we can never remember is really just taking this and dividing everything through by cosine squared. Now, if we divide it instead by what? Sine squared all the way through, same starting one. But if we divide them all by sine squared, then sine squared over sine squared would be 1. Cosine squared over sine squared would be cotangent squared. And 1 over sine squared would be cosecant squared. And I'm out of room. That's supposed to be a theta, sorry. So both of these two are just the original one divided quickly through by sine squared or cosine squared. But some of you still struggle with these, okay? The fact that tangent squared is sine over cosine, or that cosine is the reciprocal of secant, or secant is the reciprocal of cosine. You really need to have those memorized or this is going to be very slow going. All right, so at the top of your homework is this list or notes, but can you make sure you can find those on your reference sheet as well? I think they're on the back of the Trig reference sheet. The peach colored Trig reference sheet. Does everybody see where they are? Because that's where you're going to have to be able to find them for the test. Chadwick, you need to put that away. Okay. Now, these three, did you find them on the reference sheet? These three can be rewritten so many ways. So many ways. Okay. So sine squared plus cosine squared equals 1. You could subtract the cosine squared over to the other side, so that said sine squared equals 1 minus cosine squared. Or you could subtract the sine squared over to the other side. You could then change all of the signs. So I could say here negative sine squared equals negative 1 plus cosine squared. Okay, so there's things you can do to keep rearranging them. I think I have another slide here. You could factor them. So if you had 1 minus cosine squared equals sine squared, 1 minus cosine squared would factor 1 plus cosine and 1 minus cosine. Okay, so there's all kinds of things you can do to rearrange these. Are there any of the rearranged ones written on your sheet or not? Your peach sheet. I don't think so, right? Just the basic three across the top here where it says Pythagorean identities. All right. I'm going to go real fast through this section because I'm not even sure I assigned one of these on the homework because we've done so many in the past. But this says you could use trig identities to solve this. Find the tangent if you know the sign is this. I don't consider this a trig identity question. I would just draw. This means it's in quadrant 1. Sine is opposite over hypotenuse. If I had to, I would do Pythagorean theorem and get what here, guys? 4? Yes. 5 squared minus 3 squared. And then it says find the tangent. So the tangent would be opposite over adjacent or y over x. And I'd be done. These two are ridiculously easy. We don't even need to draw. If they give us the cotangent and they want the tangent, what are we doing? So the tangent would just be 5/12. If they give us the sine and they want the cosecant, what are we doing? Okay. I think you have these on your notes if anybody's, you could flip it as negative 4 over 1 or just negative 4. Okay, so we might need to draw, but we might also just be able to flip it over. I think this is more along the lines of draw. Now we're going to have to use some common sense. Oh, sorry, that's not right. Some of our all students take calculus. Okay, the cotangent is negative, so that means the tangent is also negative. So it can't be in this quadrant or this quadrant. The sine is, what does this mean? So the sine is negative. So what quadrant are we in? Yeah, because this S means the sign is positive. So we're in quadrant 4. And the cotangent is x over y or adjacent over adjacent over opposite. The negative would go on which one? Because it went down. If we did Pythagorean theorem, this would be 5. Okay? So this is adjacent over opposite. We're in the right quadrant. The sign is negative. Okay, so what's the cosine here? Yep. And the cosecant is hypotenuse over what? Over opposite. Yeah, it's because the flip of sine. So it's negative 5 over 3, 5 over negative 3, whatever. All right, are we pretty much all good at those already? Not. Okay, I have one more example here. Can I just skip it? Because I'm not even sure I assigned one of these, okay? That's old school stuff. There are some new things that you do need to know for a couple of the questions. This has to do with the even-odd identities. They are on the middle of your sheet, your reference sheet. It says odd relations and even relations. You see where it says that? Okay. If a function is odd, which sign is odd, it has origin symmetry. Then when you go to the right, say pi over 2, you get the opposite of what you would get if you went to the left pi over 2. So when you have the sign of a negative, it becomes the opposite of the sign. So the negative can move out front. Okay? That's for odd functions. So it also happens for cosecant and tangent and cotangent. These are the odd ones. All right, the even functions are those like cosine, where if I go to the right, we'll say pi over 4, and I go to the left pi over 4, I'm going to get exactly the same value because they have y-axis symmetry. So therefore, the negative can just be thrown away because left and right give you the same value. Okay? So when you have a negative inside, it goes away. So these are the even functions. And that's all on your reference sheet, not something you have to memorize. Does everybody see where it is on there? All right. Co-functions are different. The co-function means basically like the cosine of 30 degrees is equal to the sine of 60 degrees. Look at your unit circle real quick. Does that check? Looking at your unit circle, cosine of 30 degrees is square root of 3 over 2. And if I go to 60 degrees, the sine is square root of 3 over 2. Okay? It's the co-function. So the ones that go together are sine and cosine, tangent and cotangent, secant and cosecant. But you could never figure out why those didn't go together like you thought they should, right? They're not reciprocals, meaning secant and cosecant don't flip. But instead, they have to do with this comes from complementary. Do you remember complementary in geometry? It means 90 minus, okay? So secant and cosecant are equivalent when you do 90 minus. So if I had the secant of 10 degrees, it would equal the cosecant of what? 80. You take the complement of the angle. If we had the tangent of, well, let's do an easy one, pi over 4, it would be the cotangent of what's the complement of pi over 4? It's actually pi over 4, right? Because pi over 4 is 45, 90 minus 45 is still 45. All right, this is not something, these are not on the reference sheet because you're not going to need to use them as a proof until we get to the sum and difference things, okay? So I didn't put them on the reference sheet because I'm not going to ask you to do them on a quiz. All right, so for the assignment today, the basic idea is that you can apply trig identities and algebraic techniques such as substitution, factoring, simplifying fractions to simplify and rewrite trig expressions. So here are my suggestions. Are these on your notes somewhere? Start by rewriting in terms of sines and cosines. Use identities to trade or simplify. You may need factoring, may need common denominator. Okay, if you have fractions, get a common denominator. And if you have a fraction that you don't want, you can use the conjugate of the denominator to get rid of it, and we'll talk about that, okay? And it says when you get stuck, go back and start and try something different. So these are not proving yet. I'm not going to tell you where to get, which for me is always a struggle because I'm like, okay, when am I done then if you don't tell me where I'm trying to get? Well, if you want to start by rewriting these in terms of sine and cosine, what would this one become, guys? Cosecant of x would be, is that a sine or a cosine? It's 1 over sine of x. Then there's implied multiplication here. The second part is cotangent squared. If I put the words cosine and sine or sine and cosine, what does this become? Yes. And it's cosine squared over sine squared because it was cotangent squared. Did I lose anybody? On your sheet, it says cotangent is cosine over sine, so the squared applies to both. Now, we got to be real careful because it says plus 1 over sine x. I can't do anything with adding until I have a common denominator. But I can put these two together. What does this become? This was multiply. What happens if I multiply those together? 1 times cosine squared on top just becomes cosine squared. What does the bottom become? Sine times sine squared would be sine cubed. Well, that's not looking too good. Okay. Now I have two separate fractions. If I want to add, I have to have what? Only way I can add fractions is if they have a common denominator. So what is the common denominator for a sine cubed and a sine? Sine cubed. So I need to make this into a sine cubed, so I will need to multiply it by what? It already has a sine, so I'll need to multiply it by 2 more sines, sine squared. Everybody okay? Sine squared, and I'm not going to have room for the x. So then this will stay cosine squared of x over sine cubed of x. I'm writing a lot of steps here, some of which you could probably skip, but 1 times sine squared will be a sine squared of x. And then down here, sine times sine squared will be sine cubed of x. It's wrong to lose the x, the name of the angle along the way. If you do on a quiz or test, I'm not going to count it wrong. I'll probably just write it in or something, okay? I know it's when you're working on these quickly on your homework, it's easy to lose the theta or the x. Now, they have a common denominator, so now I can combine, just like when I had 1/5 plus 2/5. I added the top and kept the bottom, right? So I'm going to add the top, cosine squared of x plus sine squared of x. And I keep the bottom, so that's just a sine cubed of x. All right, now what? Anybody recognize what's going on up here? It's not tangent, though. What is cosine squared plus sine squared? 1. So we get 1 over sine cubed of x, and that was an identity. Okay, that's the trade we did there. Now, this is down to a single trig function, but what is 1 over sine? Cosecant, so it would look nicer if we just said 1 over sine cubed is just the cosecant cubed. Okay. Do you see where I say it's hard to know what you're going for when you're finished on these, okay? So try to get down to a single trig function if you can. All right, that was kind of a tricky one. Let's see where we go from here. We are distributing, maybe, right? Let's, you want to rewrite them in terms of sine and cosine first? Or as we go, at least? Cosine of x times what is tangent? And then cotangent is It is, but if we're going to put everything in terms of sine and cosine, then I don't want a tangent or a cotangent. I want everything in terms of sine and cosine. All right. So what happens here? When I multiply this times this, okay, I'd have cosine sine over cosine. What can I do then? Yeah. Everybody see that? Do you want me to write it? I'm not even sure where this is going. And then this one times this would be cosine times cosine over sine, because this is just over 1. All right, but it's not killing kittens as long as it's multiplication to just divide those out, right? So this is just sine x. Over here I have cosine squared over sine x. Is that looking any simpler? Any ideas? Yes, we need to get a common denominator. So this is currently over 1. We'll need to multiply it by sine over sine. What will that become? Plus cosine squared over sine. I'm showing a lot of steps here. But now I can add the top and keep the bottom, right? And I'll write that step out. And then what is the top the same as? And 1 over sine x is really all right. Who needs me to go back or explain a step better or show? Anybody? Okay. At some point here, I'm going to stop showing quite every little bitty step, but yikes. I don't know that I would change this all to sine and cosine to begin with, because it's going to be really messy, isn't it? I don't know. Do you want to? What would most of you do? That's fine. So the tangent would be what? I'm going to lose my x's kind of on purpose here so that we don't have so much writing. Plus, this is sine over 1. And secant is what? Okay. Down on the bottom, cosecant is times tangent, which is, oh, I think we might be in better luck in better position than we thought. Anybody see what happens? Where? Down here, we end up with 1 over cosine, right? What happens here, though, when we multiply those two together? Sine over cosine, but it says plus another sine over cosine. What is a sine over cosine plus another sine over cosine? And on the bottom, we have divided by 1 over cosine. Now, what happens when you divide by a fraction? Multiply by the reciprocal. So this becomes times cosine over 1. And then what happens? Okay, so what are we left with? 2 sine over 1, or just 2 sine? Make sure you put the x back in. I was just saving us time and energy. Do you have to know your fraction rules? Any questions? All right, what's different about this question? There's a bunch of squareds, and there's addition involving a squared. What is 1 plus tangent squared? Is it anything I can trade? Remember these guys we started the day with here? 1 plus tangent squared is a... Okay. So I'm thinking we should make that trade. Make this a trade for a secant squared. So that will give us a cosecant squared over a secant squared. Now what? Yep, we can change it to sine and cosine. What's cosecant squared? So we have a 1 over sine squared divided by, you know what? I'm going to do it this way. I'm going to write it's 1 over sine squared, and it's being divided by, right? What is secant squared? You don't have to write it that way, but it's easier for me because now I'm going to do what? Yeah, flip the second one over and flip it to multiplication. Whoops. How did my x become an exponent? That was interesting. What happens when I flip it to multiplication? I have 1 over cosine squared on the top, and at the bottom I have sine squared times 1. Is that a single trig function?
Yeah.
Cotangent. Yep. So cosecant squared over 1 plus tangent squared simplified down to just cotangent squared. We could have tried this another way. We could have tried switching the tangent squared to sine over cosine and then getting a common denominator down there. Sometimes you're not going to all approach it the same way. All right, what do you want to try on this one? You want to switch to sines and cosines, or you want to distribute first and then switch to... I'm thinking we're going to have to FOIL this all together at some point. Okay. 1 over cosine minus, what's tangent? Interesting, because what's true in that parenthesis? They have a common denominator?
Yeah.
So we could combine them into a single fraction if we want. Sine squared. Yeah, be very careful, guys. Cosine plus sine does not equal 1, okay? It's cosine squared plus sine squared. The same is true, 1 minus sine doesn't equal anything. It's 1 minus sine squared is a cosine squared. Can't use those identities unless you have the squareds. Cosecant is 1 over sine. And that one's just a plus 1. Okay. What do you want to do? I really don't think we have to FOIL. Yeah, let's rewrite this one as one fraction. 1 minus sine x over a cosine of x. If we wanted, what could we do back here to make this a single fraction? Okay, so this 1 could become a sine over sine. So then what would we have as a single fraction? You have a common denominator of sine x, 1 plus sine up here. Anybody know why that helps at all? No. Nope. Got addition and subtraction. We can't. But I can multiply these together. How does that FOIL together? 1 minus sine times 1 plus sine. One times 1 is?
1.
Okay. The middle term here and the middle term here will do what? Yes. So that's the good news, okay? It's like the difference of squares. We're FOILing it, so we get 1 minus sine squared. Now, in the denominator, we do have both a cosine and a sine, but let's not worry about it yet, because this is a trade you should recognize. If you knew that cosine squared plus sine squared equals 1, then what would happen if I subtracted that over there? I'd have cosine squared equals 1 minus sine squared. So this top trades out for a cosine squared, and then we have over a cosine times a sine. Is there any addition going on? So with no addition, we can do what? Yeah, we can divide out. And some of you maybe would need to rewrite this as cosine squared means cosine times cosine, right? You don't have to. But this is going to divide out one of these, but there's still one left. So we have a cosine over a sine, which is a... Well, the one thing about that one is it certainly looked nicer at the end than it did at the beginning, right? Oh, I'm thinking because these have squares, we should do some trading if we can right away. Okay, on your sheet, can you look for a cotangent plus 1? Is that anything or not? Okay, it says on your sheet 1 plus cotangent squared, which is the same thing except the order is different, and we can add in any order, is a cosecant squared. Okay, what is a secant squared minus 1? Well, on your sheet it says 1 plus tangent squared equals secant squared. So if I subtract this 1 over here so that it looks like this, what is secant squared minus 1? Okay. Now the good news is we don't have to FOIL anything, and there's only multiplication going on, so we could cancel, but what would we maybe want to do? Yeah, if I switch this, it would become 1 over sine. Tangent is what, guys? So what happens? The whole squared thing cancels. They're both sine squared, right? So we have 1 over cosine squared, which is a... How many of you have not had trig since last year? Okay. So some of you are going to need more practice or take more time to do these assignments because it's been a while. So you just need to keep up or it's going to be overwhelming. This is a tricky problem because I think we need a common denominator, or we need to do something, because this 1 is out here all by itself. Okay. We're going to need to combine it with whatever this is. But what is tangent squared? Is there something we could trade a tangent squared for? I don't, do you want to rewrite this in sines and cosines? I guess I looked at the sheet right away and I said, well, tangent squared is secant squared minus 1. Does everybody see that, what I'm talking about? And then I looked at the denominator and I thought, wait a minute, secant squared minus 1 factors? Secant plus 1, secant minus 1? And I have a 1 plus secant in the denominator. I'm just trying to look ahead and thinking that that might be a good way to go, but that just comes from a lot of practice, I guess. We could go sines and cosines if you want. What do you want to do? Do you want to trade this? Tangent squared is a... Oh, is that what you want to do? Okay. let's do it your way. Sine squared over cosine squared. Oops, I forgot my squared. And this is 1 plus 1 over cosine, right? Can I teach you a trick that's super helpful in these situations? What is the common denominator of this whole fraction? If I had to get all of this as a common denominator, what would it be? Cosine squared. Okay? I could make everything have a cosine squared in the denominator. But what we're going to actually do, this is a trick you do all times in calculus to get rid of complex fractions. I'm going to multiply the top of this fraction by a cosine squared and the bottom of this fraction by a cosine squared. That's legit because it's just a form of 1, right? What happens when I do that on the top? Sine squared times cosine squared divided by cosine squared just becomes... Now we got to be a little bit careful because what are we actually doing on the bottom? Distributing that cosine squared, right? So what is this cosine squared times this guy become? Cosine squared times 1 is cosine squared. And cosine squared times 1 over cosine is just... Okay. Now we still have this weird 1 plus out there. What happened is we got rid of the complex fraction. All right, now what do you want to try? To what? But it wouldn't have a common denominator. This is the common denominator, right? So we could change this, I guess, to cosine squared plus cosine over cosine squared plus cosine, because that's just 1, right? And now they have a common denominator? What happened? This is a weird way to do this problem, but it's working. Okay, what happens once you have a common denominator? You can do what? Add them together, and what happens to the denominator? It just stays, right? Yes. So what Keaton is saying is when he looks at all that, there's a cosine squared plus a sine squared, and that can be written as what? Just a 1. And then this plus cosine. Now, can I cancel something here? Nope. There's pluses and minuses gluing stuff together. But what can I do in the denominator, guys? If I keep the top this, anybody know what I could do to that denominator? No, because it's plus, not times. Zoe, any ideas? Yeah, it's not. What? Okay, guys, I know this is a weird idea to introduce right now, but can we factor something out? What could we factor out right there? Because then what would it become? Cosine of x plus 1? Is that the same thing that's on the top? Now, because they're really the same, we can divide them out, yes? This whole quantity divides out this whole quantity, so what's left? Be careful. Yeah, but the cosine is where? In the denominator, right? So it's 1 over cosine, which is secant. I don't know what else I have here. I was going to show you I could have done this one a different way. Ew, I don't think I signed one like that, so I think I'll skip that one for right now. This is going to be the assignment, and you have the bookwork. I'm going to go back and do, though, this one. When it says rewrite as an expression that does not involve a fraction, okay? So we have to do something to get rid of all the fractions. Real quick, I'm going to write this one as cosine over sine divided by 1 over cosine minus sine over cosine. What could I do right away? Down here. They have a common denominator, right? So the top is cosine over sine, but what happens down there? 1 minus sine all over cosine. Now what happens when you divide fractions? You take and multiply by the reciprocal, right? If I flip that one over, it becomes cosine over 1 minus sine. Now what do I have? Sine times 1 minus sine. This isn't going anywhere fun fast, is it? I don't know. If I replaced the top, cosine squared is 1 minus sine squared. And how does 1 minus sine squared factor? 1 minus sine times 1 plus sine. Now what can I divide out? I don't really know where I'm going with this. Now I have 1 plus sine over sine. Oh, I can separate this, guys. That's 1 over sine plus sine over sine. What's 1 over sine? And sine over sine is, so that's not nice, but does it have a fraction anymore? Yeah, that was really gross. I don't know if that's what they wanted us to do there. All right, so come with questions tomorrow. Work on these, okay, and come with questions. I will go over homework questions.